morning, everyone. Welcome to the Public Forum 1 on the CAV friendly road infrastructure. What is next? So I think it's good time today that we're going to discuss about the future of the transportation, not in Thailand, but around the world. So we have 4 international guest speakers. My name is Tongkarn Kaewchalermtong. I'm going to be your moderator today. So I think everyone ready to look forward to the future together. So without further ado, I would like to invite our first speaker. He is a Deputy Director General from the International Road Federation, Mr. Gonzalo Alcaraz.
Good morning, everyone. Thanks, moderators. Thanks also the partner Highways for the invitation. It's a pleasure to be here with you. Without further ado, let me just briefly introduce who we are. We are the International Road Federation. We are an organization based in Geneva, Switzerland. We represent somehow the road infrastructure sector around the world. We have an outreach of around 130 countries, and we divide our activities in 3 main pillars. First one is about knowledge and expertise, like what we're doing today, also building some trainings and capacity building activities. Second one is our networking. You will hear in the next slide. We organize events. Our World Congress is coming in Istanbul next month, but we also organize other type of events, and we join events also to spread and enlarge our network. We work also on policy and advocacy, mostly focused on road safety and road sustainability. And last but not least, we have been collecting information about statistics from our sector for the past 61 years, I think. So we have been collecting quite some data for the past. So if you are interested, I invite you to check our website. And as I said before, we are organizing our World Congress that is taking place in Istanbul this October. It's a gathering that we organize every 4 years, so it's very important for us. Our whole network is coming from the whole world, and we look forward to whoever is willing to come. I can offer some discounts, especially for the audience today, if you are interested. So how we are connected to this topic? A number of years ago, we decided that it was about time to start thinking about the future and what's going to happen with the road sector. And we launched a committee along with the European Union Road Federation and CAV. CAV is the tollways operators in Europe. And we try to identify somehow what's the role of the road infrastructure towards autonomous mobility. And we usually have frequent discussions about the topic. We released a document a number of years ago, what we call it the Connected and Autonomous Mobility Manifesto, that you can find on the website, and it's focusing basically on 3 topics. First one is the most obvious one, perhaps the technological aspects of all the things that are bringing into the sector and how we're using it. But most importantly as well, we are discussing about what is going to happen with the workforce, how are we going to reskill and upskill our people who is involved in these topics, and also how the regulatory frameworks are going to affect and how we are going to change our mindset regarding these topics. So next, I think it's clear for everyone. We have a number of challenges in our sector, mostly high dependence of fossil fuels. We have an inefficient routing and traffic congestion. We still have road safety concerns. As you know, millions of people are still dying on our roads due to incidents, and we are still having an uneven vehicle utilization, not optimal for what we are doing. So where this CCAM, let's say, topic come from, and I'm using the term CCAM because it's the one that is mostly used in Europe at the time, is somehow the evolution of ITS. Then it was called cooperative ITS, and now it's somehow agreed, or mostly in Europe, we are using the term CCAM, and this is pushed and mostly used. And CCAM stands for cooperative in the first place, meaning the interaction between road infrastructure and the vehicles and the cooperation among them. Second, C is connected, so of course the exchange of data in real time for many purposes. And the A stands for automated driving. So reducing or keeping minimal intervention of the human being. And of course, it will bring a sort of transformative impact on the sector, improving traffic management eventually, reducing the accidents, and lowering emissions, which is something that we need for the sector. So I'm going to just briefly go into an introduction of what really CCAN is and what it can do. Our colleagues later will go into the details. They are more expert than myself. So CCAN basically can help us to build a sort of relationship with whoever is a vehicle on the road, not only traditional vehicles, but also public transport, bicycles, motorbikes, and gathering all that data and using it for the best of the purposes we need to do to optimize flows of traffic, to lower emissions, and to reduce the hazards we can have. And this can be done using basically two types of communications. As you may know, one is through the cloud, what we call, using traditional mobile networks. And the second one is using short-range communication, using DSRC or XEG5, what is called in Europe, basically a sort of Wi-Fi for cars. So these two means of communications allows us to gather information and at the same time share information with all the vehicles. In terms of what is the type of data we can share, there are a number of standards that has been using on the sector, and here is just a list that are going to be defined by ASTRI, and we're not going to go into the details of this, but basically you can get information about what the vehicles are doing, the speed they are doing, where are they heading. At the same time, we can send information about potential hazards through events, roadworks, etc. We can send information about the signal phase and timing for a specific use case I'm going to present in a minute. We can share as well the topologies of the intersections, so understanding which lane of road is connected to a signal group of the traffic lights. We can send in-vehicle information, so the information of the traffic signs directly into the vehicle, and also we can eventually ask for priority at intersections when they are signalized. So this is just a very brief and quick introduction to the topic. One use case that has been very used in our sector and has been even implemented with some OEMs is the Green Light Optimal Speed Advice, GLOSA. This is an application I have been involved in the past. It's about providing a speed advice and eventually time to green phase when approaching an intersection. This was a mobile application that anyone can have on our phones. Of course, it requires a connection with the traffic management in the city where this is implemented, but basically it's telling us what is the speed we need to have in order to cross the next intersection with the green phase. And eventually, if we cannot do that because the limit doesn't allow us to do that, it will tell us the time to green, so how much time are we going to wait for that. And here I have just a very short video that Audi has implemented this publicly in some cities in the United States and soon in Europe. I have been also involved in my previous works in pre-development of this service, so it's good that you see it with your own eyes.
The new Car2X applications at Audi include the Traffic Light Info online service. It connects the car with a central traffic control computer, which controls all the traffic lights in the city. The system shows the driver what speed needs to be selected to pass through the next traffic light during a green phase. Selected information appears on the driver information system display. For example, when waiting for the green light, the remaining time is displayed. The system has the potential to save up to 15% carbon emissions and is fully developed in technical terms. It is connected to the car's start-stop system, which starts the engine 5 seconds before the light phase changes. The system is scalable to implement new functions. This way, you can use your time efficiently and avoid traffic jams. Audi can fit the traffic light info online service to all models.
This was just an example. Many OEMs are working on this topic, and I'm sure that this will become an standard in the future. Let me just use the last part of my presentation in something that is unique. We have developed a smart road infrastructure classification index. This was part of a Frontier project. You see it right on the screen. The idea here is try to assess and evaluate the readiness of the infrastructure towards connected and autonomous vehicles. And there are a number of, let's say, parameters that we have been considering in order to come up with this index. We are, let's say, at the first stage. We have done a lot of research on understanding what could be, and this has been translated into a sort of process, and eventually we have defined 44 parameters that we are currently inserting into this formula and giving us an output of how ready is the infrastructure or a segment of an infrastructure towards this. We started with the review, of course. We have a preliminary parameter selection based on other topics, other work done by other institutions or the sector itself. We have involved a number of experts also from different parts of the world to not be impartial and try to have as much broad inputs we can, and then we selected these parameters, and they were basically categorized in three main groups, and we have an analogy here with the body. So the first one is, let's say, the skin, so whatever is related to the physical infrastructure, what we can touch, and this refers to road markings, the signs, the geometries, the roadside elements we see on the roads, and it's basically whatever we can touch. On the second group is about the digital infrastructure, so somehow the analogy will be the brain, and this refers to the digital twin, so the digital representation of the infrastructure, the digital maps, the elements of the traffic management, the information system, and eventually as well all the localization mechanisms we use for this. And last but not least is about the connectivity, so how to connect the brain, let's say, with all the rest. And it's about what I was mentioning before, the short and long range communication, the quality, the latency, and the throughput that is essential for this type of use cases, because the vehicle is moving, it's not standing. And this is a very quick introduction as well, how these smart road assessments are done. Usually they start with the data collection. There are audits that are done on the infrastructure, either on-site or information that is gathered through other methods. The data then is processed. In most cases it's manually. Eventually in the future this will be more automated and using perhaps AI, but still not the case. And in the case of our index, we have tried to use these parameters, georeference, which reference image every 100 meters. And this eventually gives us a classification of the infrastructure going from 1 to 10. So 1 will be the lowest one. We say not smart, but this is the worst case scenario, and 10 will be the maximum support and readiness for cabs. There was also a sort of case study within the project. This was in Athens, Greece. We took a segment of a highway near Athens. This is connecting, I believe, the airport to the main city. So you see there are the points that we took, and you see then on the screen, I don't know if here, you see how it's reflected on the index. Here we are having an index around 3.5, and you see that the infrastructure is well developed, but the other points are not that much. So this gives us a sort of baseline to improve in the future and to know exactly how the infrastructure is ready for that. So just wrapping up, I think it's important to say, and in my experience working on this topic for the past 10 years, is that the future of mobility is not about the vehicles, but how we integrate those vehicles into the mobility ecosystem. And the mobility ecosystem is just the vehicles and perhaps the user, and that's all. There are a lot of factors, there are a lot of, let's say, stakeholders that are part of this, and the key point here is that we need to, whatever we do, we need to do it knowing that we need to involve everyone. And I think that will be, I think, common with all my colleagues later as well, and part of the discussion, that we need to somehow be sure that we are involving the right stakeholders in whatever we do. And of course, in this topic, there are a lot of challenges and opportunities for infrastructure, and if you position yourself in 50, 100 years away, and I like to have that vision as well, the infrastructure can change a lot, or it could be developed in a different way. As you know, we have built roads considering human error, and if we remove the human error, then the roads could be totally different. We are thinking that perhaps we might not even need signs, we might not even road markings, the roads can be the width can be changed a lot, so there is a lot of thinking about how this is going to evolve. A lot of the infrastructure also is developed in a way considering that we are driving far away from each other, but if we're driving very close to each other, then the weight we put on the road is different. So there is a studies on bridges that it might not be appropriate for the future. So this is going to basically change everything. Of course, it's going to take time, and of course, it's going to require a lot of involvement, not only from the public sector, but also the private sector. So I hope my presentation was clear. I wanted to give you a short overview of everything, and yeah, if you have any questions, you can write me there, or you can ask some question later on. Thank you so much.
Thank you so much, Gonzalo, for the good presentation. So I think we all understand the road infrastructure perspective and to connect with the CAV. And I think it's a good idea that all the manufacturers like Audi try to create the system that work with the road infrastructure in the future. So next speaker, he is the Vice President from International Sales and the General Manager Office, HwaCom Systems Taiwan. Now I would like to invite Steven Chen to speak on the panel. Thank you.
I think I didn't meet Gonzalo before until this event, but very surprised. We are gonna cover the topics very similar, and a lot of ideas all similar. So it's my honor to share our experience here with all of you regarding the CAV, or we call CV2X. Okay, so before I share what challenges we have in the transportation, I think I really want to, this is not a complaint, this is just experience. Yesterday, when I tried to call a Grab in Bangkok, 4.5 kilometers, it shows you're gonna spend 30 minutes. So this is very terrible. So we can imagine that as the population grows and also the urbanization is developing, we all face the congestion. And also coming with the congestion, we have pollution. And this pollution generated by the transportation is even more worse than manufacture. So transportation become a kind of headache for our society. And let's see, on the other hand, we also find in the industry there are a lot of self-driving cars developing in the market, and this is very successful examples in San Francisco. They have self-driving taxis, but let's see what happened. Just early of this year, the city of San Francisco is going to suspend self-driving taxi because the safety. So what is the problem from the congestion, pollution, and even the safety? For example, for the EV, the problem is that they don't have very further sight to discover the environment. all depends on the sensor. And CAV is the topic. We want to reinforce the detection of the AV to make it more safer. Don't confuse. CAV is very, very good idea, and that definitely will become the future of our life. But we need more technology to support this application. So when we talk about the intelligent transportation, again, we always talking about ADS, ADAS, etc. But a lot of people didn't very aware. Indeed, we need to have ITS as a foundation. The ITS mainly is based on the roadside. And this is what Gonzalo mentioned, that scope is going to service not only vehicles, but also the pedestrian. So let's see the mission of the ITS, safety, green, efficiency, and management. I think this is also pretty much, we share the same scope. So based on that, we believe our transportation has to migrate to green and intelligence in order to fulfill the mission for green, safety, and efficiency. So how can we make it happen? If we look at the evolution of the road, 100 years ago, 200 years ago, the road is to service the horse. And now the road is service to the vehicles. And for the next, the road should be like this way. It should be make all of the stakeholders on the road to connect it with each other in order to share information to give the safety to each other. So this is the evolution of the connected vehicle. I especially would like to highlight this is because if you look at the CAV, or we say CV here, this is the government's job because the roadside is not by the private. Private company can develop a new technology to support their vehicles to have a nice self-driving function. But government has to build very reliable and smart roadside facilities to support those AV and EV. So look at the ITS. This is the fundamental elements to become an ITS. For example, we need a lot of IoT to collect the data, just like Gonzalo mentioned. Data is so important. And the data has to be processed by the AI software. And we need to have an edge computer in order to react immediately. And everything should be following the international standard, because in the future, there's no Thai transportation, German transportation, US transportation. If you think about that, one day when Mercedes made in Germany, import to Thailand, it cannot connect it to your traffic lights. It cannot communicate with your roadside infra. They will become a disaster. So CV2X should be internationalized. Here, even though I have only 15 minutes to do the presentation, I still want to spend 3 minutes to share this Intel video. They cover the scope of the ITS.
By 2030, the world will have 41 megacities with more than 10 million inhabitants. And by 2050, 2.5 billion more people will have moved into cities around the world. These changes will have profound implications in our lives, especially when it comes to transportation infrastructure. Intel is at the leading edge of addressing these challenges with products and services that enhance our experience on the road, save us travel time, and make our roadways safer. Electronic tolling with the Intel OpenVINO toolkit automates the collection of fees. This improves traffic flow and reduces stop-and-go and idling behavior, saving both time and the environment. This same technology also supports congestion pricing scenarios in urban environments. Once inside the city, roadside units provide compute power at the edge to optimize traffic light signaling and traffic management in near real time, enhancing the efficiency of the city and helping us all move more quickly. With software capabilities such as sensor fusion, Intel is enabling multi-model sensors like video, LiDAR, and radar sensor for enhanced scene intelligence and detection of vehicles, pedestrians, and bicyclists to streamline traffic management, reducing collisions and congestion. Intel is enhancing scene intelligence through digital twin technology to combine the digital and physical worlds for optimal modeling and predictive algorithms. In addition to managing traffic load, roadside units improve pedestrian vehicular safety. Here, V2X technology provides dynamic route optimization to clear a path for emergency vehicles. Smart parking systems provide real-time updates on parking availability and have automatic payment systems, getting citizens to their destination faster and reducing congestion. EV charging stations support the influx of electric vehicles, preparing cities for the future. As computing power is distributed between the cloud and edge, Intel's Converged Edge Reference Architecture supports 5G and multi-access edge compute, offering plug-and-play development and deployment across form factors. Smart Edge Open Toolkit enables application development and network functions for the edge with cloud-like agility. Intel also supports 5G private networks that secure and streamline communications. This creates value for users, carriers, and municipalities. Intel is also investing in a number of technologies that benefit cities. Geospatial mapping and road condition monitoring keep citizens safe and provide money-saving insights through predictive maintenance. Tomorrow's infrastructure will be fully connected and integrated, optimizing city operations, improving our health and safety, protecting the environment, and achieving a rapid return on investment. And all of these advances will be powered by Intel technologies.
Look, the key word of this video is only one word, it's connected. So we foresee in the future, everything on the road should be connected with each other. And this is the major topic today. We are talking about CAV. Okay, I'm gonna cover CV2X quickly because in my two cases sharing, they were involved with CV2X. CV2X, they consist of V2V, vehicle to vehicle, and V2I, vehicle to the infra, like a traffic light. V2N, vehicle to the 5G, 4G telco. I think this is important. A lot of people confused about CV2X with the 5G operator. It's actually different. And V2P, that is vehicle connected to pedestrian. So with this scope scenario, you can easily understand in the future on the road, everything should be connected with each other. And next one, this by Audi, it can also share with you how CV2X can save people's life.
Hi, my name is Paul Malhotra. I'm Senior Director for Connected Services at Audi of America. We're here in beautiful Oceanside showing you some future technology that's going to be coming in our cars, and it's looking at improving safety on U.S. roads. 42,900 people lost their lives in 2021 because of collisions with motor vehicle accidents. This number is growing. In fact, this year, the first quarter saw a 7% increase in that number. Vulnerable road users like bicyclists are some of the worst impacted. Almost 1,000 bicyclists lose their lives every year because of crashes with motor vehicles. 130,000 are injured. This scourge needs to stop. It's a drain on our economy, and we have technology that can stop it. One of the biggest reasons that we hear when we ask motor vehicle drivers why did that collision happen is that they just didn't see the cyclist. CV2X is a technology that can actually let you see that bicyclist. This stands for Cellular Vehicle to Everything. It's a cellular communication technology that actually communicates directly. It bypasses the towers. It does not need this infrastructure that comes with 4G or 5G. That direct communication is so important because think about sending a text message and how long that takes to go through the network. Or even voice calls or data communication. It's just not fast enough when you're talking about a situation where you have an impending collision. CV2X communicates 10 times a second. And so the vehicle can be aware of something around it. The bicyclist on the other side can be aware of something around it. CV2X is a standard that's been approved by the US government for deployment in the US as the only standard that can be used for intelligent transportation systems in the 5.9 gigahertz spectrum. It is going into deployment mode. We expect about 5 million devices outside of cars to be CV2X enabled by mid-decade. That's about the time that we expect to launch vehicles equipped with this technology. And by the end of the decade, about 60 million devices outside of cars that we would be able to communicate to. You'd be able to communicate to construction workers wearing vests that have CV2X radios, so that if they come too close to the edge of a construction zone, you can avoid hitting them. They'll be equipped in school buses, so that when they extend their stop arms, then now oncoming alert of a vehicle can be sent to a vehicle. They'll be equipped in emergency vehicles so that they don't have collisions on the road.
Yeah, so with this video, I just try to get all of you, get people to feel more closer to the real life. CV2X can actually change our environment, our life. And following, I would like to share two cases which we did with the Ministry of Transportation in Taiwan. The first one we call D project. With this map, just quickly to let you have idea the location. And what we did, we have three phases. Now it's at stage 2, which covers 30 junctions in this area. And what we did is to build the infrastructure in this area to testify the CV2X to service the transportation. And we also define the T-cross. This is to make our traffic controller to follow the international standard. As Gonzalo mentioned, that they involved with a lot of protocols such as map, team, spot, for example. So everything should be connected to international standard. And we also do the bus testing, safe driving bus. And also we try a lot of ITS application in this area. The information is to share to the government, and this is the scenario what we did in this region. For example, if essential vehicles priority, and also green light wave, for example. And these sites also become. We also build the platform for these sites, for the traffic management to the government. So we apply the digital twin in these testing sites to become part of the management platform to make the authority to manage this transportation more easier. And this is a 1 minute video to interview the Minister of Transportation who was in charge of this project. Why he initiated this project?
就使得交通更智慧化，交通不再只是为了运输，从甲地到乙地，而是这个过程当中，除了安全便利，还有各种的服务。那你在这个移动的过程中的体验，已经不是工具性，它本身就是生活的一部分，它就是一个庞大的商机，也因此。这个智慧交通这个场域计划，我们选择淡海新市镇，就是希望它是一个智慧城市的缩影。那以这样的方式，就是必须要呢去整合人、车、路还有物端，变成一个生态系。透过不断的这个实证，那去收集大数据，再回来修正我们的智慧交通的规划，跟一些建设还有服务，那结合呢对路况，还有包括过去可能发生交通事故的情形，到了十字路口，我们就知道哪里是可能比较危险，那或者这个地方因为交通事故多，所以我们就会比较小心，可以透过警示的方式提醒。5G 在交通上的应用就是很多创新的服务，是这个创新的服务可以带来更好的生活品质。
Okay, and because time is quite limited, so I just go through this quickly. The second case we would like to share is the CV2X on the expressway of Taiwan. And the mission is we want to build a test for the next generation highway, which is to provide a service by V2I to service those vehicles on the highway to reduce the congestion and enhance the safety. The story is we built 10 kilometers expressway with the roadside units, And we also built CCTV in the outskirts of the local roads to provide the data. We integrate the local and expressway as a picture to manage the transportation. So this is the deployment of the roadside facilities, including roadside unit, CCTV, radar, etc. And we collect the real-time data for the decision making. And for example, we can provide if there's a roadwork, if there's a falling item, or if there's a congestion, etc., to the control center. I think this is pretty much to the current traffic management system on the expressway. But the difference is we broadcast the contents or say warning to the driver. But unfortunately, most of the private vehicles doesn't equip with the CV2X. So we rely on, we call mobile CMS. We build the display on the back of the bus, because when the bus is moving, and it can deliver the real-time message subject to the location to the driver nearby. So this is a testing. We testify this on the expressway. And also we leverage the engineer vehicles to become mobile roadside units to broadcast the alerts to the drivers as well. And we build the digital twin, again, for the management of the project and also the traffic control. So this is also the screenshot of the digital twin we built for this project. So this is land-based management platform. It's quite different from the usual traffic management of the highway. Even in Thailand, I think we don't do the land-based, but for the CV2X, that is the land-based. And this is a show video to introduce what we did in this project.
前方入口匝道回堵2公里，道路施工，注意外侧车道。
This is the showcase for the transportation, the CV2X on highway. So the conclusion is that we need safety and efficiency. So we need CV2X. But to achieve this is a chicken and egg. I always mention there's no private vehicle with the CV2X chips. Government would not spend the money with that. And the government also concerned about this. The car maker is also concerned about when there's no roadside infra. So why bother I put the chipset on my car to increase the cost? So that is the major problem and bottleneck we got here. So in the last part, I just want to share my idea in 2 minutes. This is the ITS America proposal last year. They proved CV2X is a safe technology to provide us safety to the users. And their target is to build more than 250,000 junctions with roadside units in next 10 years to make this scenario happen. So what they are going to do, they are going to apply adaptive traffic light to reduce the traffic congestion. I think in technology that is not so difficult. And also, smart public transportation rely on the adaptive traffic lights can shorten the journey time of the bus to encourage the public transportation. And also, we can provide the essential vehicle priority to the ambulance. And again, when we can create more users for this roadside infrastructure, then they will give the legitimacy to the government to spend the budget to, to implement the smart road for all of us. So this is the last video I would like to share with you by Ford Motor. So, ladies and gentlemen, thank you. Thank you.
Next speaker. So I would like to invite Dongzhe Su. He is a director of Smart Mobility, chief engineer of the V2X system communication technology ASTRI from Hong Kong. Please join me on the stage.
Thank you, moderator. Thank you all the audience. Very happy to be here to share what we have done in Hong Kong. Let me first introduce ASTRI. We are Hong Kong Applied Science Research and Institute. We are Hong Kong government funded and the largest research institute in Hong Kong. So thanks for the first two speakers. You already clearly introduced what CV2X is. Actually, we deploy V2X applications starting from 2015 in Hong Kong. At that time, it was DSRC communication between vehicles, and now it's all moving forward to CV2X direction. And of course, the whole idea is how do you make sure that the vehicles, the infrastructures, the edge, and the platform can work together smoothly, and they can trust each other. So. Let me first give you a video and see what we're doing in Hong Kong.
ASTRI is the pioneer in connected vehicle technology development in Hong Kong. With the support of the Innovation and Technology Commission and the Transport Department, ASTRI introduces one of the largest CV2X public road tests in the world on 14 kilometers of open roads from the Hong Kong Science Park to Sha Tin Town Centre, where CV2X devices are installed along the route. The ASTRI research team works day and night with our partners to build and deploy CV2X for the first ever public road test in Hong Kong.
Front left pedestrian alarm. Roundabout vehicle incoming. Do not enter. Front collision warning. Front collision warning. Left blind spot vehicle coming. Left blind spot vehicle coming. Speed limit 50. Speed limit 50. Caution ahead, please take right alternative route. Intersection alarm, front right vehicle coming. Found abnormal vehicle. Found abnormal vehicle. Found abnormal vehicle. Road work on the road ahead, please drive carefully.
So the core idea of ASTRI conducting applied research is that we conduct research targeting the next 3 or 5 years. So the video you just see that is the V2X deployment we did in 2019. At that time, we developed the roadside sensor technology. For example, how do you fuse the camera data with the LiDAR and radar data and provide a full monitoring in the intersection and in related area. And we develop different modules and license to different partners. And we also develop simulation systems. So this is an example. We need to connect, for example, to the traffic light, get to different style of traffic light and into the same V2X system, also connect to the vehicles. Of course, we know that at that time, 2019, we have to install aftermarket OBU onboard unit to the vehicle, right? And now, the major providers, actually, they have equipped V2X modules in their vehicle that's selling, already sold to you, but they may not have enabled it, just waiting for the whole city infrastructure to be upgraded to enable it. And also of course, the roadside sensing system and the city V2X server, we call it EDGE and cloud platform. And this is another example we did in 2019 that in Shanghai we partnered with Huawei and Volvo. This is a very interesting example. You can see that we're purely using roadside system and communication system to make a normal vehicle, like a very cheap vehicle, to enable its autonomous driving. So this vehicle does not have its own sensing systems, does not have its own very powerful computing capabilities, because in the car parking we call auto valet parking. It is a scenario that it is a controlled environment, and you have roadside systems that covering the major part of these scenarios, and you actually guide from the roadside and using V2X tell this vehicle to what it needs to do. So it's an extreme example that you can purely rely on, technically rely on the roadside system to do what you do. And of course, in the real cases, it's quite kind of hybrid, right? Depends on how smart the vehicle it is. So we call it CAV because the AV itself should be mapping to different tier of autonomous capabilities from L0 to L4, because we cannot move directly to the situation that all vehicles are purely smart. So this is what we are doing now in Hong Kong. The previous example shows that several years ago we deployed mainly in Sha Tin Town Center, and now we are deploying in various city challenging scenario, because you know in Hong Kong the city's situation is quite interesting. The two very tall buildings, they are very close to each other, blocking the position signal from the satellites. So we always say that if an AV or connected AV can run smoothly in Hong Kong's environment, you can deploy in everywhere in the world. So this is an example that we are doing now. We welcome all you come to Hong Kong to experience this we call it connected autonomous bus. The bus itself is L4, and we will welcome audience at the end of this year, December. So this is the environment we want to show that how day-to-day Hong Kong people we are going to use autonomous bus, or connected autonomous bus, yeah. So you can see that in this place, it's a busy roundabout, very classic Hong Kong road scenario that there's no traffic light here and there are multiple lanes. You have to really be careful when you are human driving, right? When you decide to cross the lane or not. And for AV, it would be extremely challenging. Considering the other road environment, you have this on the second level of the road networks, another roundabout. And the AV need to really decide how it interact with each other. And we know that for the first place, all the other vehicles, you should assume that they don't have connectivity, you don't have any sensor AI on it, right? So it purely rely on a lot on its own capability. So we really need a L4 vehicle to make that. So you can see the classic scenario is that we normally Hong Kong people go to MTR stations, they get out, and then they go to work or go to home. Normally, to MTR station, the subway station in Hong Kong is 5 to 6 miles. So the classic AV scenario is 2.5 kilometers travel. So that is what we are focusing on, mainly on autonomous bus. Of course, we are also going to try robotaxi. Right? With this short distance, we will have 3 roundabout. Especially for this one, it's a big, we can say, big challenge for AV. And in this scenario, normally there will be an accident blocks the whole road in every 1 or 2 weeks. So AV should be able to handle this. And the other case is you can see that the person is quite like when we are here in Thailand, right? People just move around. They don't follow rules. So how you have the AV and the V2X system to assist these vehicles here. So that is what we are going to do. In the 2 big roundabout, we will have our roadside system. The left part is in the Hong Kong Science Park. ASTRI is there. And for the 2 big roundabout, we will have the roadside system with lidars, because you have to consider the privacy issue. In Hong Kong, normally we don't use cameras, right? And use lidars to provide a full overview of this roundabout. I'm not going to get into technical details, but the key is that you have to make sure that the person, the driver, or the AV system can trust your data. That is the key challenge. So I will get into more detail later. Another example is in the the seaside of Hong Kong. They have very, very tall building here. A lot of technical challenging where we are trying to address is that how do you provide positioning services to these vehicles in a very, very crowded and busy city environment. So this is a very classical example, right? We face a lot also in Thailand when we arrive here. A lot of bridges and vehicles are there. How do they find each other before they make any decisions? And a lot of roadworks, the road maps are kind of changing, right? Sometimes there will be a roadworks in the morning, but they will remove in the afternoon. And some AV, their algorithms fully relies on the map, right? HDMI map. So how do we update these maps will be challenging. Another example is, of course, that one is the roundabout, and how do you give notice to the 2-deck bus? In Hong Kong, a lot of 2-deck buses, they kind of block the sight of others. So how do you enable the safety alarms of these kind of buses? We are testing with our partners to be able to handle that. So, of course, in Hong Kong, there are a lot of different type of vehicles, and normally we increase the penetration of the AV or V2X rates, right? Normally we go through the public vehicles. For example, the green minibus, a very popular public transportation bus, and also the engineering vehicle are those we think that will first equip V2X or a driving assistance system, and also the digitalization platform. The key is that different places, the government handles their different data in different way. So we can say that to make the vehicle system, V2X system, available for the public, the first thing is that you have to make sure the whole traffic system is digitalized and you can trust the data. So that what we are doing here. And also another interesting scenario we are handling is that you can see in Hong Kong the roads are very narrow. We have limited length of roads and narrowed roads, and we have a lot of vehicles. And we don't have the lands to test the AVs like in the American, in mainland China, right? They give a big area of roads and let those AVs to run and test. And in Hong Kong, when we land different type of AVs, we need to the first day going to this very crowded scenario I just showed you in video. So we think that the first thing is, of course, the CV2X system. We already developed the end-to-end technology. The other side is the AV system. How do you really make sure that these things two things work that together. So there are two key technology directions. One is cooperative perception. The other one is policy negotiation, right? So you need to make sure that, okay, AV from A brand comparing to the B brand, they can really talk to each other. For example, when we test Baidu AVs, they're kind of, you can say it's kind of gentlemen. They always allow other vehicles to go first, okay, when there is no traffic light. And we have partners that they kind of adopt very aggressive AV policies, and when there is a chance, it's just getting, okay, that they kind of use different AV policies. So when you manage this different type of AVs on the same narrow roads of Hong Kong, we need to make sure that, okay, one kind of AV don't bullet the other ones, okay? They should be efficiently work together. So there are definitely a lot of protocols, a lot of common interface or standard we are going to build together. Another important direction we think will affect the kind of when the real V2X world will come is that the trust between the entities. For example, when you send info from the roadside to the vehicle, now the biggest challenge is the vehicle manufacturer or the AV or the driver, they kind of don't trust it. If you send a lot of message, a lot of alarms, right? Our testers, they just turn it on and give a lot of alarm. They think that you need to handle it carefully, but the guy thinks that, okay, I know the situation, you don't need to tell me, right? So how do you filter this info, and how do you make sure that you send the info at the right time? You don't send too late, or you don't send the wrong info. So one key technology we are focusing on is we call it a time-sensitive network, because nevertheless you are going to use V2X deployment on the road, but you are not going to deploy it everywhere, especially for developing countries like China, like Thailand, right? We cannot, like every 200 meters, deploy RSU and sensors. That's impossible. We need to rely on the general network, 5G or 4G, right? But generally the 5G is okay when we look at video, TikTok videos. It's okay, it's delayed 2 seconds. But if a message, alarm and message sent to you late 2 seconds, right? It will be a misinformation. An accident will caused by the V2X system, but not saved by you. So we are trying to build, we call it a time-sensitive network. It's kind of make sure that the network system is kind of predictably stable. That if it's not stable, it will be turned down, okay? The system should be correctly communicated. So that is one of the key directions we're working on. This is a video I want to show you that we're helping the Hong Kong government to really enhancing their whole traffic system digitalization, because some of them actually are really relying on the paperwork, and when we publish it, they even have Chinese characters in different departments on the online system. So you need to really be able to absorb it into this we call it smart management platform. Another thing is we think that in the future, these type of platform, because it has too much data, too much different type of data to manage, it definitely would not be able to be managed by people, human beings. We cannot understand that anymore. So the AI system behind it can really understand the trend or the cause of each problems would be an important trend. We call it a big data model. So another direction I want to mention is that to solve the problem that we cannot deploy everything everywhere, right? We need to rely on different type of technology. For example, the LEO satellite. The satellite actually now is flying very close to us now. It provides communication and sensing capabilities, and it enables the possibilities that in long distance uncovered area, it can assist the vehicles to really communicate. So this is a direction that we are working with partners to really make sure it happens, because you cannot rely on RSUs when it's going to the far west of maybe the US or China, right? You have to rely on something. Yeah. This is how ASTRI works. We kind of deliver R&D works. When we tackling some key challenging problems, we think about it, is this a theoretical problem that the whole world cannot solve, or it's a problem that focusing on applied science. This is an example when we're handling navigation problem like in Hong Kong. The navigation is always the first challenging thing. We work with PolyU University because Hong Kong, luckily, we have several very powerful universities, but now they mostly focusing on the theoretical work. So how to bring their attention to our V2X world? This is an example that we use the roadside system with the professors and how they help us to increase the positioning capability there. So we help those professors to really find the key theoretical problems in the industry, and they don't need to tackle all the engineering, or we call it applied work research. So in all these areas, we kind of collaborate very closely with university and the industry. So we also have publications together. It kind of, all these publications are solving key problems. For example, how do you make sure that roadside sensing and can really work together with the AV sensing? Yeah, I'll skip the details. The last page I want to share is, because we are in Thailand, we are facing very similar scenario in Thailand. For example, in Hong Kong, we drive, the vehicle goes on the left side of the road, right? But in mainland China, whole mainland China on the right. Right. In Thailand and Japan are same to Hong Kong, we on the left. But all the countries surrounding Thailand is on the right. So, right, how do you, it's kind of big difference on that you know, but those government, they manage data in a different way. So how do you handle the cross-border issues and technically, and it's kind of not only involving technical R&D challenges, but also how how to manage these systems. So that would be the key challenge. So what we are doing is we're connecting the whole Hong Kong system to the mainland system in Shenzhen. Yeah. Thank you. That's my sharing.
Next speaker, I would like to invite Johnny Wang. He is a Director of Business Development APAC and China region from Tier 4. Please join me on the stage. Thank you.
Thank you, iCHE, for inviting me to speak today. I'm very happy to be with you all. My peers have covered connectivity of the CAV quite well with the background. I'm here to talk more on the autonomous vehicle side. Tier 4 is a Japanese startup. Our company is basically developing autonomous driving software solutions being used mainly in Japan, but also now globally. Today, my topic will be about V&V, or verification or validation of autonomous vehicles. So I think my peers have very clearly articulated the benefits and the need of connectivity and infrastructure and how that benefits vehicles, efficiency. But autonomous vehicles we've been talking about for many years now. It's still not very prevalent or available to the market as of yet. And the key question for that is because of safety. You still have to get it into a mature state where it's safe and efficient for the public use. So we in Japan have gone through a level 4 certification process, and I'd like to share a little bit about that with you today. So just a little bit of background about the company itself. We were a startup started in 2015, roughly about 350 employees today. As you can see from our shareholders or stakeholders, I think Gonzalo mentioned earlier in the first presentation, in order to have a CAV to be beneficial to a country, a city, a society, you need to have multiple stakeholders involved. It's not just from a technology standpoint, a vehicle standpoint, but in order to bring it to maturity, you have to get involved with connectivity, to insurance, to the public sector, to the government. And so what we have done at Tier 4 is we're more than a technology company in that we have a lot of shareholders or stakeholders involved with us that are strategically collaborative to understand the entire journey from technology to validation, to connectivity, to insurance, to the public sector. And so you'll see that within our stakeholders, we have Sompo, which is an insurance company that writes insurance policies for level 3 and level 4 driving. We have KDDI, a telecom company doing the connectivity. And so that helps us along the journey to understand when we're developing the technology, to also understand the other portions of the stakeholders that we need to think about and be sensitive to while we're developing the technology and maturing it. So one very unique thing about our company, we're not the only autonomous vehicle company, obviously. There's many in the US, there's many in China. Where we are unique is that our entire software stack, the autonomous driving software, is open source. So our founder and CEO had the wisdom back in 2015 to understand that it's going to be a long journey to bring autonomous driving to fruition. And it's going to require a lot of investment, a lot of resources, a lot of education, a lot of communication. And so that is very difficult to do by just one company. And so what he did was, at the same time as he established Tier 4, he took whatever he developed and made it open source globally to the open community. Anybody to be accessible and democratize autonomous driving technology. So we created this AutoWare Foundation, which is a nonprofit. As you can see, it's grown rapidly over the last few years. We have more than 500 companies as members, covering over 20 countries and 30 different type of vehicle types. And so this is accessible to anybody, and actually a lot of the Thailand universities and academia are also utilizing it, either for development, research, or even just reference. So many people ask me this question, so if your software, your core base of technology is actually open source and free for everybody to use, what do you actually do as a business? And so Tier 4 is a technology-enabled company. That's how we position ourselves. As I mentioned earlier, it's a long journey to bring autonomous driving to fruition. We often like to take the analogy that it's like climbing a very large mountain. And yes, you can start from the base, but it's much easier if you can hitch a ride to be able to start from the kind of the mid-mountain or the halfway point. And that's where Tier 4 comes in. We provide technology enablement in terms of reference designs, in terms of product support, hardware support, in terms of DevOps, to allow our partners, our customers, our collaborators to streamline their own development, and that especially is the case for different geographies or different countries. And so that's where we are as a technology enablement. And because our software is open source, it's very easy to work with Tier 4 in terms of that we're transparent. Now, most of our peers in the same industry is a black box. You don't really know what's going on inside the software, so you do have to trust them to be safe or to do their applications as they communicate or design. With us, everything's a white box. Everything you can see, and the beauty of it is that it's a collaborative nature with different countries, such as companies in China, companies in Europe, in Turkey, in the US, and in Southeast Asia. Everybody can contribute to the maturity of the software stack. And that's where the real kind of key to the success of our company and the development is that it's not one private company. It's a collaborative ecosystem that's global, that contributes. And that's very important because there's lots of different things that are unique to roads and roadside safety for different countries. As my peer just mentioned, Hong Kong has very tight, smaller roads compared to the US. There's different roadside infrastructure setup that's already in place in some countries and not in others. And so where it's very important is that with AutoWare and the group of collaborative partners is that they bring their own expertise, their own diverse scenarios into the greater ecosystem in which everybody can learn from each other. And we can leverage that experience and be able to mature the technology and ensure that there's more safety for autonomous vehicles in the future. So AutoWare deployments have been worldwide, as you can see here, and in all very different types of vehicles. So there is the public transport sector, which is buses, which is the main focus of late. There's also robo-taxis, shuttles. Even in Thailand, there's already some deployments in the Thailand Ayutthaya Historical Park area, which is actually also using AutoWare as part of its software stack. So for Tier 4, most of our development and our operations have been in Japan. And being a Japanese company, we work very closely with a large amount of the OEMs. So with Robotaxi, we're working with Suzuki. With larger buses, we're working with Isuzu. We also work with BYD in China for deployments of buses. So there's an assortment of different projects that we've been working on. Some of them are closed road, but a lot of them are public road, and that's the main focus point as we move towards the future. As we realize that in order to benefit society, you have to, one, be able to make the vehicle safe and that the public can trust it. Secondly, that's going to be connected to infrastructure so that everything is efficient and all of the protocols are set. And so all of those vehicles have been deployed across many, many municipalities in Japan. Now in Japan, we have a very large societal issue. It's the aging of society. So the population is not growing. By 2030, the statistics tell us that we will have 60,000 shortage of bus drivers across Japan, especially for smaller municipal cities, underserved communities. And that is a very big problem because a lot of these cities or these small towns are 75% of the population are 65 years or older, and they don't have access to public transport in the future. And so the Japanese national government has come up with a program called the Road to L4, sponsoring these smaller towns to invest in autonomous driving trials and operations. The immediate goal is by 2026 to deploy across 50 different cities. Obviously, you can see from this picture here that we are heavily involved in a lot of this. So it also covers different types of vehicles, but autonomous driving buses is probably the main vehicle that's being focused upon. Just some examples of some cities that we are already operating in. In Komatsu City, and if everybody ever visits, please contact me. We can give you a demo ride. These are actually already in operating deployment for the general public. So it does still have a safety driver, just in case, because being Japan's very conservative. We do have an L4 operation permit. So we are actually able to remove the driver if we communicate properly with the municipal government. I think currently our target is by 2026, 2027, we will be able to be at a point where we've done enough testing, enough public trials, and have the public trust to be able to do that. Right now these are operating, and fare-paying passengers are actually taking these buses as their normal daily transport. So it wasn't an easy journey to be able to go from a proof of concept to a trial to a point where you can actually certify the bus to be publicly operated. And that took a journey among a lot of communication with both the national government in Japan and the local government in Japan, and also the public sector. So it took quite some time. We went from 2023, it was the first L4 certification ever issued in Japan. Last year in October, and that was for a much easier use case, but still, granted, it's still running on public roads on transporting factory workers from the dormitory over to their facility. This year we will have the first level 4 permitted bus in Chiyoji City, and then next year we plan on doing in more dense urban area inside Tokyo for robo-taxis. So a little bit about the process, how we got there. How do we actually get this permit? So in the United States, you probably have heard of Waymo and then operating. Stephen properly articulated the issues that Cruise has got and got their licensing suspended in San Francisco. In China, there's a lot of trials that are happening. But it takes a lot of communication and trust between the government and the public to be able to get to the stage where you can actually certify a vehicle, a company, to operate at a level 4 on the public road. So this is a bit of the process that we had to go through, and the current standard process that we have in Japan. And to be honest, Tier 4, when the Japanese government started thinking about this idea of certifying vehicles, they actually didn't really know where to start. It's easy to understand how to certify a driver's license, right? That process has been in place for years. However, when you're trying to certify a technology, there's not a lot of expertise within the government to be able to understand, how do I actually validate this? How do I actually know that's safe? How do I actually trust you Tier 4 saying what you can do, that you can actually do it on a public road. So that took a lot of back and forth communication, understanding the technology, and we worked with the government together kind of to map out this process. And hopefully, the Thailand Ministry of Transport and other organizations and agencies can maybe take reference to what we've done in Japan. So yeah, I won't go through this in detail, but as you can see, it starts with obviously a document paper that you say, this is my use case, these are the roads I want to drive in, this is the policy that I have in place, this is the safety protocols, and that's all just reviewed by a group of expertise from universities, academia, and government and private companies to review that documentation. After that, you will be able to get a granting to drive in those conditions. It's kind of like a driver's license, but for the technology. And then you go through an operational permit, and then finally to usage, in which you have to communicate with the municipal local city, the police, and the regulators. So as you can see, this was the journey for our first kind of trial, and it did take quite a long time. We started in 2022 in June, and it took a little bit more than a year and a half to get to a point where we actually got the certificate to be able to say, yes, we believe it's safe for this operating design domain or this driving environment, and that you can operate. So this process, if this continues, it's going to take a long time to get autonomous driving to be deployed in the future. But this was the first time, and we've had a lot of learnings throughout this process. So one of the key areas that you have to identify during that certification process is to understand the different risk scenarios or the risk assessment. And that comes from within the ODD, the operation design domain, so where you're going to be driving, the road, the path, the route that you're driving on, what traffic lights you're going to hit, which turns are you going to make, how many lanes are you going to use, etc. So those are at a highly overview, the specifics to the operating environment that you'll be driving in. The second is outside of the operating design domain. So there's a lot that goes into those scenarios. What about rain, light rain, heavy rain? What about snow? What about fog? All of these other things, emergency vehicles, frozen roads, puddles. All of these things needs to be considered as part of your risk assessment. And there's endless amounts of different scenarios, or in our industry, what we call edge cases that you have to think about and try to solve. Now, some of that is done through simulation. Some of it's done through actual real drive testing, but you need to collect terabytes and terabytes of data to be able to say, okay, we can handle this type of scenario, and this type of scenario we can't handle. And we're not, today we're still not at that level of maturity. So most autonomous driving vehicles that are operating on the road, if it's heavy snow or it's heavy rain, they'll stop operating in most cases. So there's still some ways to go, but at least you still firstly have to understand which scenarios you are going to be able to handle in order to get your vehicle and your technology licensed and validated by the government. And then finally, malfunction. So what happens with the vehicles itself has some issue? What if it's been hacked from cybersecurity? What if there's something wrong with the onboard computer? What if one of the sensors go down? What if the cameras are covered in mud? So all of these different scenarios on the vehicle side also needs to be considered, and you also have to be able to handle that from a software standpoint. So these are some of the challenges that you will be able to see in autonomous driving when we're testing and validating, and these are actual real-world tests that we do. Now this one is done in a closed road first, but you can see there's endless amount of scenarios that you're going to have to simulate in both in the real world and in simulation to mimic, and it's endless amounts of work. So there's different devices, you have to use different mannequins, there's large-scale test courses that you have to undergo in order to be able to provide the confidence to the regulators and to the general public that your vehicle is safe and ready to go. So all of this, and I just want, why I'm sharing the experience of what we had to go through to get to this point of certifying the vehicles, is the point that you're going to realize very, very quickly there's a huge cost of validating and verifying the safety of autonomous vehicles. And most of that cost is bared by the technology provider and the OEM. And every single OEM or brand vehicle or every single technology provider has to go through that similar process or same process, which is very time consuming and it's very costly. The second thing from a government and local authority standpoint is that how do you ensure road safety for different vehicles? Every vehicle has different parameters, different horsepower, different drivetrain, different sizes. There's commercial vehicles, there's buses, there's smaller mini vehicles. So every time you change that vehicle, the government has to think about, okay, how does that scenario change for the previous work that we've done? How does that, different parameters, how do we change our validation or verification process? And that's very time consuming for the regulators and the government as well. And so what we've done and from communication with the Japanese government and other countries is the fact that we realize, hey, there's ways that we can leverage all of the certification that was done in the past and help streamline this process for future regulators or for future policy, writing policy and regulators to utilize. And so we've established a lot of third-party partnerships and collaborations. In Japan, we work very closely with an association called JARI, which helps the governments, the government contracts them to do a lot of the verification and validation of the autonomous vehicle. And so they do real-world testing, they look at simulation data, they comb through your scenarios to make sure you're not missing anything, they scrutinize your safety protocols, and that's a very good third party to be able to do some of that work. Now we also have done similar things in Korea, in Taiwan, and we're trying to do the same in Thailand and in Australia to help provide that process, that history that we've gone through over the last 3 years with the Japanese government and bring that knowledge set over to help streamline that process for other countries. So one of the key things that we're now focused upon is to say, hey, we have all of this real driving data. We also have lots of roadside data from infrastructure. There's AI systems that are currently being used to monitor or analyze troubled intersections on specific cities. And so we can utilize all that information, collect it, and then gather it and put it into virtual simulations. Whether that's a digital twin or some other type of simulator, we can gather that data to streamline that testing process so that when a vehicle or a company or an OEM comes to a new country and says, hey, I want to validate my vehicle for level 3 or level 4 driving, they can provide evidence based on data set, based on simulation to the regulatory body to say, this is my evidence of how my system is able to handle all of these scenarios. And we're looking at this in Korea and in Taiwan. What they're doing is they're taking what we've done in Japan and saying, okay, I understand that's a process, but there's a little bit of difference in driving in Korea and Taiwan and Thailand. And we need to bring those additional scenarios into the data set. And so that's what's being done, and that's a global collaboration in terms of trying to create a uniform data set to validate and verify autonomous vehicles. And I believe a large part of that is also going to be in terms of connectivity as well from an infrastructure side. How do you communicate with the infrastructure, roadside infrastructure, in order to ensure that your autonomous vehicle can utilize and the information coming from infrastructure to ensure greater safety for your vehicles. So at TFO we have this, and this is a very standard software development model called the V and V scheme. So it's the V model where you go from concept to requirements to verification, validation to real world testing, development and then real world testing. And so where we are sitting is, and my point of topic today is in terms of the regulatory body and the simulation work, you would be able to utilize from other geo governments to be able to utilize that data set. And this is what the type of model type looks like. And that doesn't have to necessarily be with Tier 4 open source software either. There's a lot of OEMs and a lot of people working on autonomous driving. whether that's level 3 or level 4, that can also get involved with similar schemes. So as an example, outside of the AutoWare Foundation, we are working very closely with an organization organized by the company ARM called SOFI, which is trying to define the future of software-defined vehicles architecture. And in that, they're defining a lot of standards in which they're contributing to ISO to be able to say a set of rules to validate autonomous driving. So we're involved with them. We're involved with among a lot of other consortiums globally as well to ensure that this system can be helpful for new countries that want to bring in autonomous driving. So just a short video about AutoWare. We're in our 9th anniversary in terms of the development that we've done, and just to give you a quick overview. So that's the end of my talk, so thank you. If anyone wants to get involved with autonomous driving in Thailand or in any other country, please, welcome to try out AutoWare, reference it. It's an easy way to start. Open source is the best way to collaborate. Yeah. Thank you.
Thank you everyone again, for sharing the idea and the concept of the CAV today. Next, we're going to have the panel discussion that we're going to dig deep inside what they just present. I think all of you might have a question in your mind, but let me start first as a moderator today. Let's start with Gonzalo. Considering your extensive experience with the cooperative intelligent transportation system, could you elaborate on the key infrastructural advancements that you are currently being developed and implemented to support V2X communication? How do these advancements address the unique challenge posed by autonomous vehicle?
Thanks. I think we have seen it already. It's about all the technologies related to communication. We have talked a lot about 5G, the use of V2X. I think that brings a radical change on the way we connect vehicles to the infrastructure, right? So the fact that we know much more about what the vehicles are doing is giving us a lot of information that in the past was perhaps gathered through physical sensors on the roads, which are very costly also to maintain and to install and to eventually to replace them. So today we can use the vehicles, let's say, as a sensor. So that basically changed everything. And that gives us a lot of information that we didn't have in the past to analyze, to improve road traffic, flows of data, etc. And at the same time, the other thing I see much more common, and it's about the use of video or data analytics through video and other means of sensing as well. We have specifically a startup label initiative within IRF, and much of the applications, if not, let's say 80% of the applications, are basically doing this, like leveraging on video or data analytics in order to understand what is happening and then using that information to somehow send it back to the vehicles or using it for improving traffic and traffic flows. Yeah.
I see. Thank you so much. Let's move to Stephen. Stephen, as you the Vice President for International Sales at the HwaCom Systems, could you share how your organization is contributing to development of the CAV-friendly infrastructure, particularly in the context of smart traffic signals and enhanced communication networks? What are the key innovations that HwaCom Systems is bringing to this space?
Okay, thank you. I think our company is focusing on the roadside infrastructure, such as the traffic lights. This is, I think this is the domain exclusively to each country. It's differently from this one to another one. Even cities in Taiwan, we have different traffic lights protocols. I think also happen in most of the world. So when we start to take this project from the governments, we spend a lot of the time to communicate with different stakeholders, because it's not easy, you know. When this ecosystem got so many players, communication is very important. And also very important thing is the trust. Like John mentioned, the trust is also kind of challenge. So that is our effort to communicate not only the governments, but also all of the stakeholders in the environments to cooperate, make sure the cooperation can be happen. So what we achieve, I think we support the Ministry of Transportation to really define a national standard for traffic controller, because as I mentioned in the presentation, for the future, when the cars, for example, even they made in China, made in Germany, made in USA, when they import to Taiwan, they has to be able to connect it to the local traffic controller, no matter what protocol, it should be the same protocol. So I believe this is the achievement we did for the industry in Taiwan.
Thank you so much. I think in Thailand here, we also have several stakeholders that in the ecosystem of transportation. Probably we might need to share out from our side as well, I mean, to solve this kind of problem too. So I also really interested about the V2X communication system that Dongzhe just shared to us. How do you envision the evolution of communication technologies impacting the future of the CAV-friendly infrastructure? What are the primary technical challenges that need to be addressed to enhance V2X integration with existing urban infrastructure?
Yes, thank you. So I think the key challenge is not we have not enough technology, but we have too many choices on the roads and following different standards, and most of them are overlapping. I'm talking about the end-to-end system. And so why communications is important, because that is the channel that no matter what you are, what you provide, you need to use this channel to provide and to get info. So as I mentioned, for example, we all know that latency and the bandwidth and stability are important. So for different capability or different frequencies, for example, the CV2X, 5.9 gigahertz, or how to use the 5G, how to use the future new evolution in the communication technology, we think that is the core base of how V2X could be adopted and really trusted by the industry or the public. Yeah.
I see. Thank you so much. Now I think Johnny, you feel really well now after you have a long presentation. So get back to you as the director of business development of the APAC and China region of the Tier 4. How do you see the roles of open source platform like AutoWare in advancing CAV-friendly infrastructures? What are the specific advantages of using open source software in the development of autonomous vehicle ecosystems?
Thank you for the question. I think it's clear that CV2X, the benefits of that, autonomous driving, everybody understands that it's coming, but it's not completely here yet. And so there's still going to be a lot of testing, validation, compliance, and compatibility between different technologies, autonomous driving software technologies with different V2X standards. And so that can be done, yes, by individual companies in each individual country. However, there's not a lot of leverage or shared knowledge set when you do that, if your system is a black box. And that's really the power of open source, is that it's accessible to everybody. And both that way you can ensure that the compatibility of your system, your autonomous driving software, to different roadside infrastructure can actually be done without bringing in so much expertise for different equipment, different standards, different frequencies, and that everything's adjustable. So that open source is really democratizes the development so that it can be trusted. At the end of the day, you need to be able to access something in order to develop it. And if everybody's developing something different, that's much more work. It's much more easier and efficient if you can base your work on open source. And I think that's our vision, is to be able to do that. And that way, things can happen quicker and safer. Yeah.
I see. Thank you so much. It seems that every country, every city requires a different thing to different cities. So, in your opinions, what do you think that each city have to develop or apply hardware platform by themselves, or somebody able to help us on this one too?
That's a great question, and that's another part of the power of open source and the hardware community, is that I think there's always, every country has they're always going to have their unique set of use cases or policies. But I think mostly 85 or 90%, and most of the government regulators we speak to in different countries have agreed to that roughly 85, 90% of driving policies can be leveraged. And it's only the last 10% that is slightly different. And so, where you don't have to start from scratch, right? You can start building upon the work that other people have done, other countries have done, and then just work on that specific, figuring out what that specific 10% difference is, and making sure that the system is compatible and safe for that, or validated for that. I think that's where I think there's mainly agreement in which you can, don't start from scratch. Basically, take a shortcut, utilize something that's been done before.
Yeah, thank you so much. I think that's a good idea, because I believe that many cities or many government don't want to start from zero. They want to start from somewhere else and go fast enough to implement the CAV in the future. So again, thank you so much. And Gonzalo, I get back to you. Given the rapid development of the connected autonomous vehicle, what roles do you foresee the public and private partnerships play in building necessary infrastructure? Can you share some successful case studies where such collaboration have led tangible advancement in the CAV-friendly infrastructure?
Yeah, sure. I think we don't have any other choice, right? I mean, if we don't involve the private sector in these kind of initiatives, how could the public sector do it alone? First, in some cases, they don't have enough resources and knowledge about what they should be doing, especially handling innovations or things that nobody has done before. That's very tricky. And then also guarantees on how that there is a viability on the business side, right? The private sector will be involved because there is a potential benefit to them, and they're going to push for that. And I think that's the right balance to find, and that might be the tricky thing to do. But I think there are many cases around the world, and doesn't come specifically for me, but I think in Europe and the US there are a number of initiatives at city level where you see that they are like using their spaces or creating these sort of innovation hubs where they somehow borrow the infrastructure for the private sector to come up and try and prove that whatever they're doing is has an impact, a positive impact on society, etc. I think, it's the way to go. We had no other choice. But before I close this, I wanted to say something regarding to your topic, because you said there are many technologies and it's difficult to do that in that way. But I think the other thing or potential mistake we're doing is that we want to do as many use cases we want or we can at the same time. And that's, I think, overcomplicates a lot of things, right? I think I see that common in many of the discussions. I think we were try to somehow get our life simpler and simplify the use cases and focus on the things that work. I think that that's important to mention.
Thank you so much. Actually, I have a few questions for one question more for you. I have heard about the other models for the partnership, like a public-private community partnership. So what do you think about how to bring and get people involved with the CAV development in the future? Gonzalo.
Can you repeat? Because
I have heard that there are also other partnership model. Now I just asked you about the public-private partnership, right? I have heard also public-private community partnership also. What do you think about to bring in communities involved with the CAV development earlier stage?
Yeah, I think that's quite simple. In most of the projects that are involved in Europe, the user is one of the key fundamental aspects of it. So everything is built around the user. At the end of the day, we're doing this because we want to save life, right? We need to bring some benefits to the society. So the user, it will be always at the forefront of whatever we're doing, because at the end of the day, is the ones that are suffering the most. If you read the statistics about road fatalities and incidents, mostly is bikes, pedestrians, vulnerable road users are the ones that have the worst results, and not the people inside the vehicle, right? So I think that's easy, and that's the approach that I see moving forward. Yeah.
Thank you so much. Now get back to you, Stephen. Considering the rapid advancement of communication technologies such as 5G, how do you foresee this development influencing the future of the CAV-friendly infrastructure? What are the critical factors that will determine the success of integrating this technology into existing urban framework?
Okay, first of all, I still like to do something like I usually do. 5G is different from V2X, because V2X can be survived without 5G. They got their own advantage. For example, V2X, such as V2B, V2I, that's their distance is shorter than 5G's, and what they provide is to broadcast the contents of the environment to the stakeholder of the road, such as the drivers or pedestrians. So this is what we are promoting to support the AV. But on the other hand, especially at this moment, we don't see so many onboard units on the private vehicles. So what we can leverage is to adopt the 5G as an internet to broadcast the information to driver on the vehicles, maybe through the mobile phone or some other devices, which is not V2X. So what I say is 5G at this moment can support V2X in a transforming period of time. But you know, it's a kind of challenge. You need to promote ideas to make people to adopt it. As what I usually say, technology, if people doesn't use it, that means there's no value for the technology. So this is the idea we have to break through.
Thank you so much. Now, I think, Dongzhe, you mentioned a lot of projects, the local CAV projects in Hong Kong. What have been the most significant barriers to develop and deploying the CAV-friendly infrastructure? How have this challenge has been addressed, and what strategy would you recommend for other cities like Bangkok facing similar issues? Thank you.
Yeah, thank you. I just answer back because you're talking about the practical way how to make things happen. We need to start with the simple use cases. Not, for example, from the academic work, we always want to one solution to solve everything, right? So that the first answers your question. In Hong Kong, actually, we did it with, started with simple cases. For example, you need to connect with the lamppost first. Right? Originally, you cannot even get that data. Very old lampposts in Hong Kong, right? And in China, we tested we can reverse control that. traffic light. For example, I think in US you have this dynamic adjustment, right? But that in Hong Kong, the old version does not support this function, right? They don't even have the time. You have to use AI to learn the. Well, that's very complicated. But as you said, we start with the typical cases. For example, what we care a lot in Hong Kong is a minibus. If you look at the traffic accident, minibus takes an important portion of it because it drives very fast. In Hong Kong, it normally tries to reach the highest speed. And in that case, we first started V2X enable on the minibus and how to use the roadside infrastructure to really make these vehicles safe. And also the other situation is engineering vehicle. Right? Those vehicles are normally managed by the government bureaus. It's not, right? Normal people buy a car, right? So it's more easy to first step get into these situations that make sure that all these important vehicles are connected and enable safety and efficiency. So that is the first milestone we are doing. And also the second one is that how to really make sure that the L4 AV can safely get into the environment here, because normally we do a trial like 2 or 3 AVs, right? You cannot buy a group like big AVs, right? So how you have to test, for example, in Thailand, if you have to try the challenging scenarios. Make sure that you don't go to the easy ways, okay? So if you really want this happens, you try the most challenging scenarios. So because we believe that if we really believe in it, we cannot find those, just for leaders of industry to take pictures, to take shows. And you have to narrow down that what are the core challenges you need to tackle because the traffic situation and challenging scenarios are totally different. For example, as we are deploying the V2X, the minibus issue, we find out that, there's a navigation issue we have to handle in the, you cannot, if you broadcast the wrong position of yourself, right? So we invest a lot to work with universities to how to handle the reflection of the satellite signals between buildings to increase the navigation. For example, in Thailand, you go out from a subway, you use your mobile phone, you can help yourself find a way, right? That cannot happen in Hong Kong, in the island. You're definitely going to nowhere. In Thailand, right, the second phase I suggest is that you try to find the challenging scenarios and narrow it down, and then you can vastly replicate. Eventually, we want the public to trust it because, for example, in mainland in Wuhan, previously they run the robotaxi, they really have some accident. And when they post it on, everyone sees the accident. They don't look at the successful videos. Repeatedly, they broadcast the failed ones. So, yes, that would be a very interesting, carefully manages the trials. Yeah, thank you.
Thank you so much. So now I still have a question in my mind about you, Johnny. So you mentioned about the auto-wear. So the cybersecurity came up to my mind. So actually the cybersecurity also the critical issue that concern in development of autonomous vehicle, especially when using open source platform. How Tier 4 addressing this challenge and what measures are in place to ensure security and reliability of the CAV system developing using auto-wear?
Thank you. This common misperception that open source means less secure. It's actually not any more or less secure than a non-open source system. The importance of cybersecurity is obviously vastly important given the trend of connected autonomous vehicles. The key issue here is there's two sides of to answer this question. So the automotive OEMs are obviously have to make sure the vehicle is safe both from an automotive certification standards standpoint and a cybersecurity certification standpoint. So that means at the lowest level of that vehicle, the vehicle control unit needs to be secure. And that responsibility actually, in most cases, will rely on the vehicle manufacturer, the OEM themselves. Now, where the autonomous driving software plays a critical role is that now it's not a human driver anymore. It's the software that's connected to the vehicle and telling it what to do. And so that layer, that lower, middle, and application layer of that software also needs to be secure at every single layer and every single interface and protocol. And so you have to really put safety in mind at the onset when you're starting to design that vehicle, the vehicle system. And so what we do at Tier 4 is we obviously try to follow international cybersecurity standards like ISO 21434 as a basis for designing the entire system. And the other part that, because there's no real standardization yet for autonomous driving software, there is no ISO for level 4 software. And so what we are trying to do now is to make sure that we are future-proofed for future vehicle development. And how that happening is, as an example, is we're involved with a company like ARM, like Sophie, like we work with a lot of the chipset providers like Intel, Horizon Robotics, NVIDIA, to make sure that we work with them so there's communication and interfacing in which we provide input into future design of their chipsets to ensure that it's easy for not just open source AutoWare, but any other software to be able to be integrated with those chips easily with the cybersecurity function. And that's what our planning is. And right now there's already a working group on cybersecurity within AutoWare itself, but also within Sophie. Mainly it's just to define, if anybody's here is a software engineer, is to define what that safety island looks like in terms of redundancy and making sure that there is a safety island for both the vehicle control but also the autonomous driving software section. Yeah, so hopefully that answers your question in a few sentences. Yeah.
Okay, thank you so much, Johnny. I think everybody feel really happy that when they talk about the open source software, it's not just free software, but it's also really secure software too. So now again to you, Gonzalo. I really interested when you make a presentation about iCHE, the index that you talk about, index for the road infrastructure. Can you explain about this one a little bit and how Thailand able to implement into this one too?
Yes, I mean, it could be pretty straightforward. I mean, it's just a matter of getting the information and getting the parameters we need for any road segments you want in Thailand, and we will be able to calculate it. I mean, we have a number of members that will be interested in doing that for you. So I think it could be also a good way to assess and check what are you doing. So yeah, feel free to contact me. I mean, that's something we can arrange.
Thank you so much. Actually, I would like to continue with you too. In your work with the International Road Federation, you have been involved in various state-of-art projects. What are some of the most promising real-world examples of the CAV-friendly infrastructure that you have encountered? And what lessons can be drawn from this project for broader implementation?
I think the best example on this is a project that is done in Michigan in the United States. They have a portion of the network that is or is meant to be fully dedicated for connected and autonomous vehicles. And I think it's one of the only cases in the world that is doing that. There's a company actually working on that, and that is called CAV. And I think it's a great approach because it's very difficult today to have a portion of the network that can be allocated only for this type of vehicles. And their approach is that let's try to build something that is very future-looking, also considering the width of the road, because of course you don't need 4 meters. You can handle everything on perhaps 2.5 meters, so it's optimal for the space as well. So I think that will be the example. I would say there are other examples in Europe. For instance, there is the the Vienna to Rotterdam corridor, going through 3 countries, that has been implemented, I think, for the past 20 years, but it's mainly focusing on the connected part, not the automated part. In Europe, they are quite conservative, and it will take a little bit more time. But I think I have seen other cases, perhaps in the Middle East, in Qatar or Saudi Arabia, where they are like having very state-of-the-art portions of the network that can be used for CAVs. But yeah, those will be the examples. And just very quickly, you mentioned, you did a question before about the difference in the different countries, and from the road infrastructure perspective, that's a huge topic, because a minor difference can basically change completely the situation. If you should think about, for instance, traffic lights and the usage of traffic lights, how the amber, the red, and the green are used. There are basically different in every country. Also, the operating speeds are different. The way of handling roads, the type of vehicles that you see on the roads. For instance, I was in Nepal last year, and 80% of the vehicles are motorcycles. That's changed completely the situation on the road. So I think it's an interesting topic, perhaps not for today, but for the future to discuss also that.
Okay, thank you so much. Steven, you mentioned a lot about the United States case study in the presentation. So in your view, what is the most effective approach to break this impasse and accelerated deployment of the CAV infrastructure?
Well, I think the strategy is to get all the people together. Because this transportation is not a solo game. On the street, you have a car, you have a people, you have even the animals, and you have many different kind of behavior when people is driving. So the best idea is to take this technology to change people's life. For example, resolve the congestion or provide safety and invite public transportation, for example, ambulance. I think this is the most easy way to make it happen, because if you expect Audi, Mercedes, BMW to put the chip on deck, I think that would be another loop of the chicken and egg. So we just try to get some users to join this advantage of technology and let them feel this is useful. And then this is the power to drive the government to spend their budget to improve the infrastructure. And then this is like right foot, left foot, right foot, left, move a little bit, move a little bit. That is how we work. So this is, I think, what we need to do, like public transportation and emergency vehicles should be the first step.
Okay, and one more question. I think it's going to be the last question for me too. Okay. Should the focus on advancement infrastructure first, or should effort prioritize vehicle readiness first? In your opinion?
Well, I think, again, similar like what I answered. In terms of government spending, that is a political subject. Why government spend money to something which nobody use? They be challenged in the parliaments or, So again, we need to create some scenario. For example, in terms of the public transportation, we talk to the city government and bus operator. Then can we design an express bus line, for example, in Bangkok? We can start from the outskirts of the Bangkok to build express bus to the city center of Bangkok. And we put the adaptive traffic lights to give the priority to the bus. So when this express bus come into the city center, they can save the time, 20%. So they will encourage people to take the bus. And in that way, government has no burden to spend the money, because I'm doing something for ESG and net zero emission, and also encourage the public transportation so they can spend the money. And when people get the benefits of express bus, then perhaps they can reduce the dependence of the private vehicles in the Bangkok. It can reduce the congestion. So this side move a little bit, that side move a little bit. So I think we can start from a story, a small story, and focus on one topic to make it happen. Then when we have adaptive traffic lights in some particular intersections, then those AV can start to try to test if they can also get a benefit of that. And more, this is the migration of the civilization, I think. Thank you.
Thank you so much. Due to the limited of the time, we don't have much left. After this, I would like to thank you all the international speakers. Please join me thank you them with a big hand. And we're looking forward to have a good discussion like this in the next year if you have time to join us again. So thank you DOH for organizing this event, and thank you every audience who participate in this session as well. I would like to thank you again. ขอบคุณครับ
First one, may I invite Dr. Tongkarn as a representative of ITS Thailand for the brief presentation, please. Thank you very much. And then next, I'd like to invite Mr. Gonzalo Alcaraz for the gift presentation as well. Thank you very much. And also next, I'd like to invite Mr. Stephen Chen, please. Thank you very much. Then that will be the turn of Mr. Dongzhe Su, please. And last but not least, Mr. Johnny Wang. A very big thanks to all speakers and also ITS Thailand.